Hey guys, Gordy again. Okay, I got a 1980 YZ125 crank on here, and got a nice bearing sleeve. It's got an oil hole in it, but who cares? It works. This had spun the bearing off of here, and because where the bearing was and the seal was all chewed up, I'm making it out of one piece here. And this is just a McGill MI12 inner race, and it's about 10 thousandths oversized, so when I drive it on there I can turn this back down to where I got about a thousandths press fit, and I will show more on that later. But as for right now, I'm got a tool in here upside down so I can cut my radius a little bit bigger in here to keep the strength up, even though I've turned the idea of this down about 100 thousandths, so that I got 50 thousandths per side on this thing. I have to bore this thing out too. So yeah. Okay, this surface right here is, focus, stupid camera, there it goes. This surface here is where your bearing race is going to center up against anyway, and you don't really want to mess with that at all. So what you want to do is take a thousandths feeler gauge, and where your tool bit goes in right here, slide it between it. And I don't have three hands to do this, but you see what I mean. Just run it in there until you trap it, just real lightly, so you can slide it back and forth, and that way you know you're not actually touching that, but you're going to get close enough to it, you're not going to affect it by making a stress riser. Okay, here it is again. It's been beaten, banged on a little bit. You can see they got screwdriver marks and stuff on here where people tried to pry it apart. And on the end here where they mashed on it with a sledgehammer to try and get it apart. I almost have to run a die over those threads. But there it is, clean back up. I just barely kissed that, so it's fine. The radius is back in it. There was actually a pit in here from where water and oil that had turned acidic had sat in it, so I got the pit out of it, so there's no longer a place for a crack to start. So now on to making the bushing fit, and then this will be a usable crank again. Okay, boring this bushing out. You'll hear it here in just a second when it hits the next step, how hard that stuff is. It cuts it, but wow. So I think I chose the right material to make this bushing out of. The chips coming out of it are dark purple. Okay, bushings to size now. Thing I have to do now is the radius on here needs to be turned onto the bushing itself, or the repair sleeve. So this is a 3/64 radius gauge, and it's a little bit smaller, but smaller is okay, and I'll show you why. Here's your radius on your crank. Now, what you don't want to, let me do that better. What you don't want to happen is, you don't want to put your bushing on there with a sharp, I mean, I'm going to exaggerate this because it'll obviously go together, but you don't want it to have a sharp corner on it like that. Conversely, you don't want to have it have too shallow of a radius on it, because if you have too wide of a radius, it ends up doing that and digging in right here. So what you want to do is make your radius shallower, like that. So it actually touches up against here instead of making a stress riser up here, which is what it'll do if you make it too big, because it won't actually get off of there, because my drawing is not to scale, but the diameter of this is actually, the radius goes all the way up to, say, about right here. So you're going to still be in the radius with the edge of your bushing, which is going to dig in right there, or more like, say, right here, and can potentially lead to making a stress riser that'll start to crack. So in summation, you want your radius on your bushing to look like that, if that makes sense, because that way the bearing's going to hold it on there, because the bearing will be pressed on over it. Sorry, I'm trying to draw through the camera here. So it'll hold it on there, and it'll still be bumped up against here, so you'll be fine. You don't need to have it all the way up against that corner, because it doesn't make any difference. As long as you're not getting into this radius where you're actually structurally weakening the crank. Okay, folks, here's the finished product. Bushing's on here, the oil hole, the seal's in front of it, and the bearing's behind it. Doesn't matter. The book doesn't list a spec on what to make the interference on this, but I made it like between, best I can measure, 1/2 and 3/4 of a thousandth, which is fine for this size bearing for what it's doing. I took a Dremel tool and just made this match right here. So I just barely kissed right here, right there, and then back here I just made it blend, so you can see it blends perfectly. So the seal will slip over it, and then I polished the whole thing down to size. I got it like, you know, within 1/2 a thousandth, and then I just polished it, and the polishing took all the high spots off, and then bang, it's the right size. And because this is a bearing race, you know, it polished up incredibly well, so the seal's not going to get into it or anything, and should run for a long time. So if you have any old pressed together 2- or 4-stroke crankshaft that you can't get anymore like this, the 1980 YZ125, you can't get new flywheels for them or crank parts or anything. All you can get's a rod kit. But if you need a rod and it's beat the bearing out of it too, you're kind of done. So if you need repair work done, just give me a call. I charge $100 to do this, and you have a new crankshaft that's usable again. So need help, give me a call.